Introducing gas chromatography with Vernier. Vernier's gas chromatograph, the Mini-GC, represents breakthrough technology for science educators teaching organic, general, and even high school chemistry. Based on patented technology developed by Seacoast Science, the Mini-GC is the size of a small shoebox and uses room air as a carrier gas. What's the best part? It costs thousands of dollars less than a traditional GC. Let's take a look at the Mini-GC's features and a few easy steps for getting started. We're here to show you the Vernier Mini-GC gas chromatograph. This gas chromatograph can work either with a computer, either Macintosh or Windows, or with our handheld LabQuest interface. Connects through any of those devices through a USB cable. And the Mini-GC comes in this plastic carrying case with all the cables you need, including that USB cable, and also with a lab manual with 5 labs that we've already written for you to get you started going with the Mini gas chromatograph.
I'll give you a little tour of the outside of the Mini-GC and describe some of the inner workings of the device. It uses air as a carrier gas, and the inlet port for that is found in the back, right here, where you could also connect a tank of argon or helium or nitrogen if you wish. There is on the top a couple of items of interest. There is an injection port here, where the samples are inserted into the device, and then a little viewing screen that gives you an update of temperature and flow rate. Next to the viewing screen is a little LED that shows you the status of the device. It's either red if it's in pause or getting ready mode, and green when it's collecting data. It inside has an 11-meter capillary column. At the end of that column is a new type of technology called a MEMS chip that Seacoast Science has patented, and that MEMS chip measures a capacitance change as the gases exit the column. Now, are we ready to do a little sample experiment?
Yes, let's do an injection.
Okay. First thing, we've got it all powered up and ready to run, and so on the side is the on-off switch for the Mini-GC, so I'm just going to press that. And you'll notice that a fan comes on, so it gets a little bit loud here in our little setup. And the Mini-GC now is in warm-up mode, and Robin will start up Logger Pro on computer.
So we're going to demonstrate this on a computer, but everything that we're going to do here can also be done on the LabQuest. So I've launched our Logger Pro software on the computer, and to start things off, I'm just going to click on the Collect button.
When you click Collect in Logger Pro, it doesn't start the data collection like our other sensors. It sets up a data collection profile for the Mini-GC that has several parts to the profile. What I'm going to do for this experiment and my mixture of organic substances is I'm going to start the temperature at 40 degrees and hold that for 1 minute. I'm going to increase the ramp rate to 10 degrees C per minute and set the final temperature at 60 degrees C. I will hold that for 5 minutes. My total length of time will be 8, and I'm going to slow the pressure to 4 kilopascals, and that will slow the ramp rate. Now that I've got my profile in place, I will click Done on the computer, and this warms up and sets the flow rate on the Mini-GC.
So it now says inject and click collect simultaneously, so I'm going to be ready to start the computer collecting data while Jack is ready to inject our sample. He's pulling some of the sample through.
And now what I'm doing here, and this is very, very rough, is getting about 0.2 microliter of liquid from my little vial to inject into the Mini-GC. So this is one of the syringes that come with this device, and we pop it into the injection port and scooch it down. And now the trick here is that I will inject and Robin will click collect at the same time. So ready, go. Okay. And now you can see on the computer screen the readings from the Mini-GC are in millivolts, and the x-axis is elapsed time. And what we hope to see, if our parameters of temperature and pressure are set properly, that fairly soon the first substance will have traveled through the capillary column and will be picked up by the detector. And when that happens, the millivolt readings will change rather quickly and drastically on the computer screen. First substance coming out of the column, and they've been read by the detector. And now we will see how good our profile is, because we do have two other substances in our mixture. And if we've done everything right, there should be a small gap on the graph between the first peak and the next peak. And the graph is showing that our first substance has passed through the column and the detector, and now we are waiting on substance number 2. And we will let this gas chromatogram develop and come back to you in a moment to look at our final plot and the data analysis. Now we're back and the run is complete, and notice that we have 3 distinct peaks. The profile that we set up was pretty good in that it shows us the 3 substances in the mixture. The shape of the peaks we would like to have look more like the first one you see than the other 2, but we have a graph that we can analyze and take the first step in identifying our substances and give you a good example of how the data are graphed and then analyzed after the experiment with our Logger Pro software. One note, all of this can be done on a LabQuest, and it would be operating the same way, and the plot would look the same. It would just be a smaller screen. So a LabQuest runs the same way with the Mini GC. Now, for analysis, there is a feature in Logger Pro software that's new under the Analyze menu that's called Peak Integration. When I select Peak Integration, I get a small dialog box with an active graph, and I can select each one of these graphs, each one of the peaks, excuse me, one at a time to analyze. All that I need to do to analyze each peak is to place my cursor on one end of the peak, hold my clicker down, and drag across the peak to get the region that I want to analyze. And then below that graph in my dialog box, I click Add. It does 2 things instantly. It determines the retention time for that substance, and it calculates the integral, so I now have a peak area. I am given a generic label. It tells me that this is peak 1. I can change that if I happen to know exactly what the substance is, but I'm going to leave it at peak 1 right now. For the second peak, I do the same thing. I place my cursor on one side of the peak and drag to capture the region around the second peak and click Add again. This is peak 2. And notice that I've got a retention time and a peak area calculated. And then I will do the same thing for the third peak and click Add one last time. And now notice that in my dialog box I have identified each of the 3 peaks, and the retention times and integrals have been calculated. Now by clicking OK in the dialog box, the information is transferred to the main graph screen in Logger Pro. So now I have each peak labeled on the graph, and below it there's a text box that describes my peaks as 1, 2, and 3. The retention times are given in that text box, as well as the peak areas, and finally the relative percent of the total area of each one of the peaks. This information can help me understand more about the substances in the mixture, or if I happen to have run the standards to before, I can identify each one of the peaks based on their position and their peak height based on the parameters of temperature and flow rate that I had set earlier.
So we think the Vernier Mini GC is a great little device. Compared to traditional GCs, it's very small, very convenient. You don't need a tank of gas. It uses just the ambient room air. The price is extremely low compared to traditional GCs as well. You can use either a computer or your LabQuest, and it would be a great addition to a high school classroom, a college general chemistry classroom, or an organic lab. And so if you have any further questions, please feel free to give us a call.